So here's some of the Chapter 4 word problems, and we'll start with one that's not quite so complicated. We have that two numbers total up to 83 and have a difference of 17. Remember, in this chapter, we're allowed to use two different variables for each of our unknowns. So we're going to have an x and we're going to have a y. X is going to represent our first number, and y is going to represent our second number. And what we want to think about is we have two equations that we're going to need to set up because we have two variables. So if we look at the statement, the first part of the statement, it says two numbers total is 83. So we have that x plus y has got to equal 83. And then we have our second statement, and we'll write this one in orange. And it says we have to have a difference of 17. So we're going to take my first number and deduct my second number, and we'll get 17 from that difference. So now we can solve for either one of our variables in either equation, and I'll just take this second one and solve for x. So I would add y to both sides, yielding x is equal to 17 plus y. And now in the very first equation, anywhere I see x, I can substitute in what I know about x. So I'm going to go to that first equation, and I'm going to plug in this right here for x, because that's what I know x is equivalent to. So I have 17 plus y, and we're always going to use parentheses, even though in this case there's a 1 in front of my x, and so it's understood that I have a 1 out front of here, and then 1 times all that stuff inside is not really going to change it, but that's okay. It's a good idea to use those parentheses anyway. And then we need to add y, and that will be equivalent to 83. So that's just taking this first equation right here and plugging in for x, wherever I saw x to begin with. So this was my x. Then I can have just one variable, so I have y's in here now, and I can solve. So I'll change my color to black and go ahead and combine like terms. So I have a 17 plus 2y is equal to 83. And then I can subtract 17 from both sides, and I get 2y is equal to 66, and then when I divide through by 2 on both sides, I get that y is equal to 33. Then I can use that value to plug into either one of these original equations and find what x is equal to. And since we already solved for x in the second one here, it's actually better to go ahead and use that one. So we're going to say x is equal to 17 plus 33, because that's what I had for y in that second equation. And so then I can add those two together, and I get my answer of x is equal to 50. And I could check both of those. I can find that the difference between the two is 17 and that they sum up to 83, and that's always a good check. And so my x is 50 and my y is 33, and I'm all done. On this problem, we did a similar one in class, and this is the standard type of problem you will see in Chapter 4, where we have information about tickets, and we have adult tickets, and we have children tickets. And so we're going to find two different equations, and we're going to let x be equal to the number of adult tickets, and y be equal to the number of children tickets. And so what we'll find out is we have 3 adults and 4 children, and their combined amount of money that they have to pay for it is $159. So we've got 3 x's and 4 y's combined up to a total amount of money of $159. The problem we did in class looked at how many we had of things and then how much, and that is a standard type of problem. But in this one, we just have information about the price, but we have 2 different kind of combinations of tickets. This being combination number 1, and then we will find combination number 2, which is that 2 adults and 3 children must pay $112. So we have our 2 equations, and then we could solve by graphing or solve by substitution, and I will let you guys do that by yourselves, and I will simply just jot the answer down here in just a second. So to save time, I am just going to give you the answer. So if you are still working, go ahead and press pause right now and finish working it out, and then you'll be able to check the answer, which is that the adults tickets cost $29 per piece, and the children's tickets cost $18 a piece. If you don't get that and you need help solving this one, just come see me during office hours. On any problems that give you a shape or a board length or a rectangle or a triangle, it's always a good idea to go ahead and draw those. And so we have this nice rectangle built in here to represent our sign. And this one talks about the perimeter, and so we do have a formula for perimeter of a rectangle, but it's always just a good idea to remember that perimeter simply means add up all the outside. So we know that our perimeter is equal to 144 inches, so when we travel all the way around the outside of it, we'll have measured a total of 144 inches. Also, we know that the length is 12 inches longer than the width. Well, if this one's my length and this one's my width, we know that it's going to take two lengths and two widths added together to get our perimeter. And so we can say that two lengths plus two widths is going to give us 144. Or if you wanted to write it all the way out, you could say length plus width plus length plus width, and that would give us reduced this original equation. We know that the width is less than the length, and so if we wanted to write a statement about the length, we could say that it is the width plus 12, because we know that it is 12 inches longer than the width. And so now we have a statement for L, and that's easy to substitute in right here into my first equation and easily solve. And what I'll do again is we've set up the two equations. You go ahead and solve them, press pause, and I will give you the answer in just a second. So when we solve, we should get that the length is equal to 42 inches. It's always a good idea to add labels. And then we get that the width is 30 inches. And it's a good idea to check and make sure that both statements hold true. So 42 is 12 inches more than 30. Yes, that works. And then if we add all the sides together, so 42 plus 30 plus 42 plus 30, all the way around the outside, do we get 144? Yes, we do. This problem looks a lot like the problem we did in class, where we're going to have a number, a count type of equation, and then we are going to have a worth type of equation. So we've got two different things here. We've got that they originally sold them for $9.50 a piece, but we don't know how many they sold at $9.50. So this will be the number sold at $9.50. And then they sold some at $2 less, or $7.50. So we want to find the number sold at $7.50. Okay? So we're going to write two different equations, one being the worth and one being the amount. So we'll start with the amount, and then we'll do the worth, and we'll do it in a different color. So if we start with the amount one, well, we see that they sold a total of 90 pieces. So that means the number that they sold at $9.50 and the number that they sold at $7.50 have to add together to give us 90. So we've got x plus y is equal to 90. And then we want to write our worth statement. So in this one, we've got some amount sold at $9.50 and then some amount sold at $7.50. We want to make sure that we put those values, the amount of money that it costs, into this worth statement, because we are talking about how much money. So we have $9.50 that they made off of a certain amount, and then they have $7.50 that they earned off of another amount of pottery. And that gave us a total of $721. Now that we have both of the equations, we can easily solve, and so I'll let you do that, and I will give you the answer in just a second. So now you should get, when you get done solving, that they sold 23 of them at $9.50, and they weren't selling enough, so that's why they reduced their price. And they ended up selling a total of 67 when they reduced it to $7.50.